This puzzle is called Limited Chaos by AnalyticalNinja. So this is a chaos construction puzzle, so we don't know where the regions are. And we have to figure out where the 4 regions are during the solve. And each circle belongs to a different region, and the digit in the circle indicates the number of cells in that circle's region that it can see in that row or column, including itself. So if this was a 3, let's say, then this region could be something like this. So because it can't take this cell, so it could be something like this, or it could be something like this. Of course, this digit could be something different. It could just be like a 2, something like this, and then have it spread up or down or something like that. Yeah, uh, something sort of like cave puzzles, if you're familiar with those pencil puzzles. I do not know how hard this is. I'll put a link to the puzzle down below if you want to give it a try yourself. Let's take a look. So yeah, so the first thing is that it says each circle belongs to a different region, so that's probably the first step, is to just color them all differently. Now, what numbers are possible? Okay, so I think the important thing is to note that the number 1 is not possible. If this was in a circle, sorry. It's not possible in a circle. If there was a 1, that would mean blue doesn't go anywhere. It doesn't see any other cells in the region, but the regions need to be orthogonally connected. Like you could have this be a region, but you can't have like this and this be blue. Like, no, that's not how it works. It all needs to connect, at least by the sides, like this, orthogonally. That's what orthogonally means, by the sides. So you can never have a 1 in there, because that would mean it doesn't see any of its neighbors. So that means that this must be, in this column, this must be the 1. Now, we don't know what necessarily what, actually we do know what, this must be blue, because, that's the only region that could reach here. Green can't come down and reach it because it's only 4 cells large. Yellow couldn't, like, that's obviously way too big. So that's gonna be blue. But I think more importantly, whoops, this is 2, 3, 4, which means one of these, exactly one of these, is going to be a 4, which means, oh no, that's a little bit more complicated than I thought, actually. This could be the 4. I didn't think about blue being the 4. Yellow cannot be the 4. That I can tell you. If yellow was 4, that would be yellow's region. So now what number goes into pink? It can't be another 4. It could be a 2 or a 3. But it can't get 4 cells without going all the way across, and it can't be a 4, which it would be if it went all the way across. So we know yellow's not 4. I did not think about blue being 4. Yeah, my thought was that pink was going to be 4, because that kind of puts the 4, off by itself, so it doesn't interfere with other regions. But this could be a 4 because it could go down 1 and then, horizontally 3, which would then mean green would go down like this, and that would work fine, I think. Then this would, no, that wouldn't work either. That wouldn't work either. So if this was 4, it would have to fill every single spot available to it, which would be like this. Now green is the only thing that can reach down underneath blue, so this would have to take all of that. Now, how do yellow and pink fill this space? Only pink can reach this cell. Now that we have had green come down here, pink is the only one that can reach this cell, but it can't go across. Similarly, yellow is the only one that can reach here, but it can't go 4 across either. So, yeah. It wasn't as simple as I thought it was going to be, but it wasn't that much harder. This must be the 4, which means pink must go all the way across. Yeah. Blue is either takes this cell or doesn't take this cell, so I'm not sure where to go with that. But yellow must take at least 1 extra cell, I guess. I could have colored that earlier. It's either just these 2 or it's 1, 2, 3. green could be 2, 3, or 4. Yeah, 4 would be, there's a lot of variety with 4. Hmm. This is a tricky one. I'm not super familiar with cave logic. I know that this isn't exactly cave logic, because cave puzzles have like walls and caves, but they do have the same circle that shows the number of cells it sees in the region, or in the cave puzzle. Let's see, if this is 2, that would mean it would have to extend out this way, which seems perfectly fine to me. And that actually works. This could be 2, 3, 4, and that would work just fine, but just because one way works fine doesn't mean it's necessarily the solution. If this was 2, let's say this is 2, that would mean this doesn't extend anymore, and this could go like this. Oh no, but if this is 2, okay, that's the problem. If this is 2, yellow has to come down. Because it can't keep going in a direction where the circle would see. But if that would make this a 3, but it would also need to come and take another cell that blue can see, the blue circle can see. But there are no other cells that the blue circle could see. So this can't be 2, this must be 3, this must be 2. Which means this must come like this. This must take this cell. And then this must take a cell as well. This must be yellow. Because yeah, if we made this yellow, then nothing could reach here. This would be just a segregated cell. So this must be like this, and then this must be 4 with the, whoops, not with the yellow, with the green. Okay, so this is a 1, 3 pair, just to finish the row, but yellow already has a 3, so that finishes like that. We need a 1 in green, and there's a 1 down here. We need a 3 in blue, and there we go. Finish that off. That was tricky. But yeah, some very good logic here to figure out the regions, and then it just solved pretty quickly from there. Great job with that puzzle, Analytical Ninja. That was a good first puzzle of the day for a very snowy morning. So thank you for the puzzle, and thank you all for watching.